wabarakatuh. My name is Muhammad Shakirin, and today I will represent to you guys about the title, which is problem. In problem, we have two parts, which is part 1, that water distribution system arithmetic sequence, and part 2, waste management facility with geometric sequence. For the part 1, which is water distribution system, the water tank can hold a total of X liter of water. The system need to distribute water to n houses, with each house receiving a different amount of water. The amount of water decreases by a fixed amount, forming an arithmetic sequence for each subsequent house, starting from the first house which get the most. And for the part 2, which is waste management facility, the waste generated by the resident increases over the time. The amount of waste produced follow a geometric sequence where each year the amount of waste increases by a fixed ratio due to the population growth of the housing complex. You need to model the increase in waste and calculate how much waste the facility will need to process after a certain number of years. So for the part 1, the problem is you have to find how much water decreases in tank when it's supplied to the first house. While the part 2, which is waste management facilities, is you have to calculate the amount of waste for each year and calculate how much waste the facility. So that means how much facility need to process after a certain number of years. Okay, that's all. Okay, hello guys. Today I will present to you about the title, conclusion. So we start from to sum up. The water distribution system is generally effective in meeting demand, but requires some improvement to achieve optimal performance. So from what I say, I mean is the water distribution system is playing great effectively on meeting demand for the houses, so it can supply the water more effectively, but it still needs some requirement to make it more to make it have a great performance, so it can be more functionally. So next is to ensure balance within the model. The tank's capacity should be prioritized over the distributed amount to prevent shortage or overflow. So from this, I mean to make a model, to make the model balance, the tank capacity should be prioritized. That means we have to focus on the tank capacity over the distributed amount to prevent shortage or overflow. So mean we have to prevent the tank capacity from the water to overflow. So that means the water that out so many. So additionally, the system efficiency can be enhanced by increasing the tank size or adjusting the distribution interval. So how can we do to prevent this problem? We have to make the tank size more large, or maybe adjusting the distribution interval, so it can reduce the chance for overflow can happen. In the next, we have our finding also indicate that the waste management facility can handle current waste level as long as waste production remain within capacity. So from what it says, is our finding also indicate that the waste management facility can handle current waste level as long as waste production remain within capacity. So from the mean that our waste management facility still can handle waste production even for many years. So it's play a role part for facilities that still have a great performance to still keep the waste production even in a long time. However, as waste generation increase over time, expanding the facility capacity and
Hi, I Aisha Alisha Alia binti Muhammad Rashidi, AA 240672. I'm going to talk about the introduction for the case study. For the introduction, managing resource like water and waste is a major challenge in modern housing development, and growing communities require systems that are effective now and adaptable for the future. This report focuses on two key problems. The first one is fair distribution of water to residents, and the second one is to handling the growing amount of waste. So for the first problem, the water distribution system, the objective for it is distribute a fixed amount of water to several houses fairly. So the method that we use here is water is allocated following a gradual decrease. The first house received the most water, each subsequent house received slightly less, ensures fairness while staying within the tank capacity. The requirement for it is to calculate how much water each house should get and verify that the total water distribution does not exceed tank capacity. The second problem is the waste management system. The objective for it is to manage the growing waste produced as more residents move in. The growth pattern is waste production increase yearly by a percentage. So the challenge is to ensure the facilities can handle the rising demand over time and to make adjustment if the facility's capacity is insufficient, such as increase capacity or improve efficiently. The mathematical modeling for water distribution is to use arithmetic sequence to allocate water to houses and evaluate sustainability of the system. For the waste management is to use a geometric sequence to project waste growth over time and to assess the facility's ability to meet future demand. So the evaluation and recommendation for it is to assess the performance of both systems and suggest improvement where need to ensure for the water system is fair and sustainable distribution. Meanwhile, for waste management is ability to handle increasing waste. That's all.
Hi, I Aisha Alisha Alia. I'm talking about the Fila table. The first category is the water distribution system, which is use the arithmetic sequence. The fact is the water tank has a capacity of some liters. Water is distributed to n house, and each house receives less water than the previous one by a fixed amount. The total amount of water distributed must not exceed X liters. The idea is to use the formula for the sum of an arithmetic sequence and adjust the A1 water for the first house, D or N to ensure the total water is less than the X. The third one is evaluate the fairness, which is does each house receive the enough water. The learning issues is how does changing A or D affect the total water distribution. The second one is what happens if n number of house is increased or decreased. And the third one is are there other ways to distribute water more fairly while staying within X. So the action plan is to calculate water distributed per house using the arithmetic sequence formula. The second one is to ensure the Sn less than x by adjusting the A1, D or N. And then the third one is evaluate whether the distribution is equitable and sustainable. The fourth one is document finding and recommendation. So for waste management facilities, which is use the geometric sequence, the facts for it is the waste increase each year following a geometric sequence. The second one is initial waste produced is W1. The growth ratio of waste each year is R. The total generated over n years is Sn. So the ideas for it is to use the formula for the sum of geometric sequence. And the second one is calculate future waste and check if the facilities can handle it. And the third one is suggest strategies if the facility excess capacity. The learning issues is how does the growth ratio R influence waste generation over time. And the second one is how do small adjustment in the facility capacity impact long-term sustainability. And the third one is what real-world factor might change waste growth rates. The action plan for it is to calculate waste produced each year using the geometric sequence formula. And the second one is sum the total waste for n years and compare to the facility capacities. And the third one is propose adjustment if need. And the last but not least, evaluate long-term impact of waste on the facilities.
Okay, hi, Assalamualaikum, my name is Tanafika Nada binti Tuan Supriya Hadi. So I would like to talk about the solution of our part 1 is water distribution system. So we will use arithmetic sequence. The water tank can hold a total of 15,000 liters of water. The system needs to distribute water to 10 houses, which is house receiving a different amount of water. So for the tank capacity, we have 15,000 liters with 10 houses. The first house, it will get 800 liters and will decrease 50 liters per house. We calculate as 10 equal to 10 over 2 open bracket 2 times 800 plus 10 minus 1 times 50 close bracket, and we will get 10,250 liters, and that 10,260 liters is below X, which is 15,000 liters. Okay, for the tank capacity with the total of the 15,000 liters, it is enough for 10 houses with the fixed amount, which is 50 liters per house. The system is effective to a greater extent, but just needed a few adjustments to give optimal performance, such as increasing the size of the tank or adjusting the distribution interval. Okay, for the part 2 problem, waste management facility, we use geometric sequence. For the facility capacity, we have 650 kilogram. Initial waste is 80 kilogram. Growth ratio is 1.5, and we have 4 years. For the formula, we use as n equal W open bracket R power n, and then minus 1 close bracket, and then we over all of that with R minus 1. Okay, with the formula we calculate the S1, S2 and S3 for the 4 years. So for the S1, we got 80 kilogram. For the S2, we got 200 kilogram. For the S3, we got 380 kilogram. And for S4, we got 650 kilogram. From the result, we can see that the total waste of produce over 4 years is equal to the capacity of the water management facility, which is also 650 kilogram. In addition, strategies used to effectively manage waste can be done by increasing facility capacity and implementation waste reduction measures.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Harif bin Mizarul Aswadi from section 4 of Algebra. So today I will continue our presentation in the discussion part. So from our discussion, we have ensured that the water distribution system has been examined to see if it will able to meet the demand. From the initial calculation we made, the results show that this system is great, but it need a few adjustments to give it the optimal performance. For example, to solve the um, what to solve the water demand problem, we can increase the size of the tank or the distribution interval. This will also help to balance the system, as well as preventing any overflow or shortage. Additionally, we also evaluate the waste management facility in terms of their capacity to handle the increasing amount of waste over time. By using a geometrical arrangement, our initial calculation show that the growth rates and waste generation play a key role in determining whether the facility can meet long-term demand. So from our result, we have obtained that the facility can function properly in the scope of the waste produced, but not exceeding the capacity of the facility. As for our strategy, we decided to increase the facility capacity and implementing the waste reduction measure. This will also ensure the system and functionally this will also ensure that the system is functionally and resilient for a couple more years. So that's all from the discussion part for me. I'll give the next discussion to my friend to continue.
Waste reduction measure will be necessary to address long-term challenge. So by what I mean is to face in the long term challenge, which you can say maybe the waste production can be increased in the long year. We have to increase facility capacity and implementing waste reduction measure, so it can prevent from the waste production to more overload from capacity. So that's all from me. Thank you.